read an article about STEPS in Model Aviation magazine. At the time, I was very interested in radio-controlled sailplanes, and noticing that the program was 70 miles away, I contacted Dr. Heimdall to the possibility of observing the program. But the real thrill was observing the excitement the girls got from learning. STEPS is a program with proven results. Based on the data from the first 3 years of the program, a girl going through the STEPS program is 8 times as likely to go into engineering as a girl who has not gone through STEPS. The following video segment, produced at Stout, describes the program well. After the initial years, tuition was not free, but demand remained high.
On behalf of the faculty and staff of the University of Wisconsin Stout, I would like to welcome you to our CD-ROM that documents the technical activities of the STEPS for Girls program. I am Pete Heimdall, Associate Dean of the College of Technology, Engineering, and Management at UW-Stout, and also the Executive Director of the STEPS program. I am pleased that you are referring to the CD-ROM. That means that you are interested in joining us in a very worthwhile project, the inspiration of young women to follow careers in engineering, science, and technology. STEPS for Girls was started at UW-Stout in the summer of 1997. We were responding to the lack of women in engineering and felt that it was very important to reach young women at an early age, in our case 12 years old, in order to give them information about these exciting career opportunities, early enough for them to prepare themselves properly as they pass through middle and high school. We have been very fortunate to team up with a strong partner, the Education Foundation of the Society of Manufacturing Engineers, SME, in this effort. SME was our first and most consistent sponsor, and more importantly had the vision to see the potential for expanding the program nationally. With the goal of developing 50 new STEPS for Girls sites at campuses in 11 industrial states, SME has secured funding already to replicate the program in Minnesota in 2000 and possibly Michigan in 2002. The summer camp accommodates 40 girls per week for 4 weeks each summer, for an annual total of 160 campers. Because of sponsors such as SME, the camp is tuition free. As a result, demand is extraordinary. We turn away up to 400 applicants from the state of Wisconsin annually, so the need for replication is evident. Our technical activities are designed to illustrate the processes and systems developed and used by manufacturing engineers. After our first year in 1997, we saw the potential for focusing these technical activities on the manufacture of a radio-controlled model airplane. The resulting integration of the activities is one of the major strengths of the program. However, considerable effort is required up front to ensure the quality of this instruction. This CD-ROM will make the planning process considerably easier for those campuses involved in the SME STEPS for Girls replication program. Welcome to the world of STEPS for Girls. We at UW-Stout are glad that you are considering joining us.
Initially nervous about attending and thinking the camp would be boring, by the end of the week we wanted to be duct taped to our beds so we could stay longer. STEPS expanded your mind and your self-esteem. It was flattering to be accepted from all the 7th grade girls in Wisconsin. My daughter attended the STEPS program 2 summers ago in 1999. She has gained so much from it I can't put it into words. Her self-confidence has skyrocketed to the moon. Her grades have followed. Old grades were 2.5 to 2.7 range. Since the program, 3.7 to 4.0. Yes, straight A's a couple of times. Our entire family attributes the change to the STEPS program. The gliders are built in a manufacturing process with stations for each task with many jigs used. As each task is completed, the glider along with the student moves to the next station. In a relatively short period of time, the glider is complete. Most of the glider is built from foam board. The wing is cut with a hot wire from blue foam and covered with contact paper. In this operation, we cut the wing panel using a hot wire. This is a jig for cutting the angle in the wing. Now the panels are glued together with hot glue. In the plastics lab, the glider canopies are vacuum formed. In the foundry, a lead nose weight is molded. "40 gliders complete. The radio control unit can be easily switched between gliders." The girls take many other classes also, some not related directly to building the glider, but more related to the manufacturing process. In flight simulator class, the girls fly a simulated model airplane through a computer. In this class, the girls have to put together a completely disassembled computer and make it functional. In the robotics class, I couldn't believe how engaged the girls were with the lecture. Rigorous physical activities are part of S.T.E.P.S as well. Some of it's team building, while other activities are more of an individual effort. Wall climbing requires not only physical strength, but problem-solving skills as well. Flight night is where all 40 airplanes are flown in one evening. Radio equipment and power pod is quickly moved between the airplanes. An experienced radio control pilot flies the plane up to a safe training altitude, and then each girl gets a chance to try the controls on their airplane. Every time a new plane is launched, everyone lets out a cheer. It is always a thrill to see something you have built fly.